Nearly zero energy building means a building that has very high energy performance, so has good fabric and uses and efficient services. And then the nearly zero, very low amount of energy, should be covered to a very significant extent by energy from renewable sources, including those on-site or nearby. So the directive requires us to have on-site or nearby renewables. And then major renovation means the renovation of a building where more than 25% of the surface area of the building undergoes renovation. So they're definitions from the directive. Just to show, I think it's an important point for dwellings, so I'm going to run through dwellings first. So I think it's an important point to say that we've done a lot of the heavy lifting in dwellings, and this review of Part L of the building regulations is not a big change for dwellings. In 2007 we introduced a 40% improvement over 2005 regulations and introduced a typical dwelling would achieve a BER of B1. In 2011 a 60% improvement, and a typical BER was A3. And this current revision is to achieve a 70% improvement over 2005, and a typical BER will be an A2 to achieve NZEB. So, but the point I really want to make here is that we've done a lot of the heavy lifting. In 2007 we were already. In 2007 we introduced mandatory renewables. In 2011 we advanced the fabrics standards quite significantly. So in 2018 we don't have as much to do. How are we implementing NZEB-Dwellings? So SI4 of 2017 amended the building regulations to include the EPBD definition of NZEB. TGDL 2011 Dwellings was amended on the 22nd of February 2017 to say that the maximum permitted energy performance coefficient and the maximum permitted carbon performance coefficient for dwellings will be 0.3 and 0.35, representing a 70% improvement over 2005 standards. And then we also committed to doing a full review of Part L for nearly zero energy building dwellings in the first half of 2018. And that's taken place now, and it's currently out for public consultation, and the public consultation closes on the 8th of June, so all your comments are very much welcome and appreciated. Achieving compliance with Part L of the building regulations. There's two parts to it. You have to achieve overall building compliance, and the new draft Part L will be to achieve the MPEPC of 0.3 and 0.35, and then you have to achieve the minimum threshold level compliance for the different parts of Part L. So the renewable energy ratio, so we're changing from an absolute value of 10 kilowatt hours per metre squared to a renewable energy ratio of 0.2, which represents 20% of the total energy use of the building should come from renewable energy. The building fabric, the backstops have been advanced, so we've moved the backstop for walls from 0.21 to 0.18. That means a full fill cavity with EPS insulation won't achieve the backstop anymore. You'll need additional insulation on top of that. Thermal bridging, there's guidance on thermal bridging, and the acceptable construction details are available. And then the other point that the other change that we've made to Part L is we've advanced the air tightness from 7 metres cubed per hour per metre squared to 5 metres cubed per hour per metre squared. We have minimum requirements for boiler efficiency, mechanical ventilation system efficiency. We also have a requirement for construction quality and commissioning, and importantly, and more importantly, as buildings become more advanced, for user information. And when you've complied with both those aspects, when you show overall compliance in deep, and when you meet all the minimum threshold levels, including renewables, building fabric, building services efficiency, and handover information, then you've achieved compliance with Part L of the building regulations. So for people who are familiar with TGDL dwellings, the main changes to TGDL dwellings of 2018, well, first of all, there's the improvement in the overall performance to achieve the maximum permitted energy performance coefficient of 0.30, and for carbon 0.35, representing the 70% improvement. Introduction of major renovations to a cost optimal level where technically, functionally and economically feasible. To summarise that briefly, where you're doing more than 25% of the surface area of a building, you should achieve a cost optimal level, and where we've written that is that you can either achieve 125 kilowatt hours per metre squared per year, or alternatively you can follow a menu of options which includes upgrading your attic insulation, replacing your boiler, and improving the wall insulation. The introduction of the renewable energy ratio, the RER of 20%, to replace the 10 kilowatt hours per metre squared per year thermal, or 4 kilowatt hours per metre squared per year electrical. The reduction of the air tightness backstop from 7 metres cubed per hour to 5 metres cubed per hour per metre squared. This is driving mechanical ventilation, and that's why we've revised TGDF, and we're also introducing a validation scheme by a competent independent third party to check ventilation in TGDF. The reduction of the wall backstop U value from 0.21 to 0.18. We're reducing the window backstop from 1.6 to 1.4. So 1.6 is good double glazing, 1.4 and 1.3 are the best double glazing you can get. The next step change will be to bring it down to 1, which is triple glazing. So we're not requiring triple glazing as the backstop, we're just requiring good double glazing as the backstop. We've included guidance to avoid overheating in dwellings. Paragraph 1.3.25, we've removed the variation of U value with percentage glazing, because the U value of glazing, so the energy performance of glazing doesn't just depend on the U value, it also depends on the solar transmittance. Secondly, we've advanced the backstop to 1.4. And thirdly, you need to advance your glazing performance in any case to achieve the overall energy performance for the dwelling. So we've removed that variation of U value with percentage glazing because it's picked up in other ways, and we wanted to make the regulations simpler. We wanted to reduce some of the complication there. Overview of key changes to TGDF. So we're doing TGDF in parallel with TGDL, they're both related. So I suppose what we're saying in TGDF is that where your air permeability is less than or equal to 3 metres cubed per hour per metre squared, TGDF advises that you should use mechanical ventilation. We've included guidance for continuous mechanical extract ventilation. That wasn't included in TGDF before. We're proposing to introduce a certification scheme for ventilation systems when they're installed. So the installer will install the mechanical ventilation system, he will commission it, and then we'll have a third party, like possibly the air tightness testers, or a scheme running in parallel with the air tightness testers, where a competent third party will come in and validate the ventilation flow rates for the systems that are installed to TGDF. We've added some examples for apartments, and we've also produced an installation and commissioning guide for ventilation systems to tell the installers how to install and commission those systems. The main changes, so in TGDL Appendix C, we've had a semi-detached house, and it's been a typical example. We've updated that typical example in Appendix C of TGDL, and the main changes, so this will give you a real feel for the impact of the changes to a semi-detached dwelling. So we have a gas boiler example with PV, and in the 2011 Part L, it required 7.9 metres squared of photovoltaics. In the 2018 example, it requires 8.63 metres squared of photovoltaics. So an increase there of about 10% in the photovoltaics. In the 2011 example, we had double glazing of 1.4 watts per metre squared Kelvin. In the 2018 example, we have triple glazing of 0.9. So the glazing has changed from double glazing to triple glazing. We've modified the DEEP calculation methodology, and we've published that with the Part L public consultation. LED lighting now will be accounted for in DEEP. It wasn't accounted for previously, so you're going to get credit for using LED lighting. You're also going to get credit for installing or having efficient hot water use and using efficient showers and taps. And then we've added an additional example of heat pumps, and we've also added additional examples of apartments in the TGDL. And we've also included a mechanical ventilation included in examples. So if you want to get a real feel for what the changes are between TGDL 2011 and TGDL 2018, go to Appendix C and you'll see the examples there in the consultation document. So when we compare TGDL 2011 to TGDL 2018, I have a TGDL 2018 heated by mains gas and heated by a heat pump. We can see that the primary energy drops from 56 to 43 or 42. The CO2 emissions drops from 10 to 8 or 7. The The energy performance coefficient, which shows the improvement over 2005, drops from 0.4 to 0.3 or 0.28. The CPC drops from 0.37 to 0.28 or 0.24. And the renewable energy ratio in 2011 was 0.18. And in TGDL 2018, it's 0.24 and 0.35. So we need to go above the 20% in order to achieve overall compliance. Major renovations, so we say where more than 25% of the surface of the building is renovated. The cost optimal performance to be achieved is 125 kilowatt hours per metre squared. Or alternatively, where you do a major renovation to the external walls, you upgrade the insulation at ceiling level where it has poor U values, you replace your oil or gas boilers where they're more than 15 years old and have a poor efficiency, or you replace poorly performing electric storage heating. So they're the two alternatives for major renovations. Important, this is the question I'm getting asked a lot. When does it apply? TGDL, the draft TGDL Dwellings 2018 is proposed to apply to new dwellings commencing construction from the 1st of April 2019, subject to transition. So you have 1 year for transition arrangements. So if you have planning permission before the 1st of April 2019, which will be most of the dwellings in design today and maybe for the next few months. So if you have planning permission before the 1st of April 2019, you have up until the 31st of March 2020 to reach substantial completion. So, from today, you have, almost 2 years to reach substantial completion. So, you have up till the 31st of March 2020. We plan to have the new regulations signed by the end of July of this year, and we plan to have the new version of DEEP out in September of this year. So all the new tools will be available for design in September of this year, but anything that's in design now has up until the 31st of March 2020 to achieve substantial completion. Regulatory impact assessments, just I'm conscious of time, and just say we modelled 5 different dwelling types. We applied various different packages to it. The average uplift in cost was 1.9% or just under 2%. And the range of uplift was 0.7 to 4.2%. So, but when you look at the examples that were published in our public consultation, they're all around the 2% uplift in cost. We've done an overheating risk. Again, we did 5 dwelling types, and all dwellings passed with a small amount of mitigation, such as reduced solar transmittance or appropriate use of blinds. We've also modelled high-rise apartment blocks, multiple-storey apartment blocks were modelled. Photovoltaics with gas boilers were viable up to 12 floors. We ran out of roof space at 12 floors, but we were able to do models with heat pumps and viable for all heights. And there's different configurations of heat pumps that you can install, like exhaust air heat pumps, communal heat pumps on each floor. They were the main ones that we modelled. Lot of training programs. Waterford Wexford ETB are developing vocational skills. DIT are doing training courses. CPD, such as this here today. SEAI will be facilitating DEEP updates. Qualibuild has a curriculum there for training providers. SOLAS, third level institutes. I think importantly, NSAI have their certification schemes for thermal bridging, air tightness, window energy performance, external wall insulation, cavity wall insulation and windows. So there's certification schemes there available as well. Just don't get frightened by the number of documents. It's not that, even though there's a lot of pages, what we've done is we've done most of it as tracked changes. I would recommend, this public consultation closes on Friday the 8th of June, but I would recommend if you're going to look at the public consultation, I'd suggest you go to the regulatory impact, the calculations, calculations for Part L 2018 technical guidance document dwellings. That kind of gives an overview of the calculations we've done. Then I'd suggest that you go to the second document, technical guidance document L Dwellings 2018. It's all tracked changes in the TGDL. I think anybody who's familiar with TGDL will be able to read through that in half an hour, 45 minutes for TGDL. And then I suggest maybe to go to TGDF for the public consultation columns. And then I think something that's really useful that we've put out in the public consultation is we've published our 6 example dwellings. They're the last 6 links on the bottom of the page. E1.1, E1.2, E1.3, E1.4. So you can actually download the spreadsheet. You can put in your own example dwellings and see what you need to do to comply for your own example dwellings. So I'll go through buildings other than dwellings then as well. Okay, just to say that for public consultations it closes the 8th of June, so please get your comments in by then. Part L, buildings other than dwellings. We work very closely with the OPW and the forensic labs and with the HSE, the Department of Education, and SEAI. We're always working closely with SEAI in developing these regulations, and we ran a lot of models for TGDL buildings other than dwellings. It was published in December 2017, so it's been available for the last 5 months. Its application is from the 1st of January 2019, subject to transition. You have 1 year to get to wall plate level. So buildings that have planning permission now have up until the 31st of December 2019 to get to wall plate level. So that's the transition period again. Okay, so the key components of the changes to buildings other than dwellings provides an improvement in performance in the order of 60% over 2008 TGDL for buildings other than dwellings. There's an advanced fabric specification, advanced services and lighting. In buildings other than dwellings, we have a renewable energy ratio of 20%, but we found when we were running the models that there wasn't enough space on the roof in some confined office buildings to get to 20% if you were using PV. So we've introduced a flexibility that where you perform 10% better than the building regulations require for the overall energy performance, you can reduce your renewables to 10%. So there's flexibility there for buildings other than dwellings, and it also applies, we've also introduced major innovations into buildings other than dwellings. Just to say that unlike dwellings is a small change, and you know, people are familiar with dwellings and what's required for advanced performing dwellings. This is a significant change to buildings other than dwellings. It's a 60% improvement in the fabric and services, and it's the introduction of a mandatory requirement for renewables. So this is a step change for buildings other than dwellings, and the industry are finding it more challenging, and that's the feedback that we're getting. Again, you have to comply with overall compliance, and you have to achieve the minimum threshold level for renewables, building fabric, building services, construction quality, and user information. Just an important difference between buildings other than dwellings and dwellings. In dwellings, the EPC is 0.3 and 0.35, so effectively you have to be 70% better than a 2005 dwelling. For buildings other than dwellings, what we've done is we've advanced the performance of the reference dwelling by 60%. So the actual building just has to match the performance of the reference building, and therefore the MPEPC is 1 and the MPCPC is 1.15. So the actual building just has to match the performance of the reference building, and that means that the MPEPC, so because they're the same, when you divide the actual building by the reference building, the energy performance is 1, because the reference building has already achieved that 60% improvement in energy performance. And then similarly for the carbon performance, it's 1.15. Performance specifications, so they're not quite in the reference, this is the performance specification for the reference building. They're not quite as advanced as the example for dwellings. Walls is 1.18, roofs is 0.15, and floors 0.15. Thermal bridging is the actual length of the key junctions by the psi values in the SBEM or in the TGDL. Air permeability is 5 meters cubed per hour per meter squared, where your floor area is less than 250 meters squared, and 3 meters cubed per hour per meter squared, where your floor area is greater than 250 meters squared. While window U value is 1.4 and solar energy transmittance is 0.4. 91% efficient gas boiler, seasonal energy efficiency ratio of 4.5 and 3.6 for your cooling systems, and lighting efficiency of 65 lumens per circuit watt, automated controls for occupancy and daylight control. 1.8 watts per litre per second SFPs, specific fan power, and variable speed control of fans, and your renewable energy ratio is 20%. So that's your reference building for buildings and dwellings. So as I said previously, you have the flexibility where you match the reference dwelling or the reference building performance. Your renewable energy ratio is 20%, where you're 10% better than your reference building. Your renewable energy ratio is 10%. So you get a credit there for improving the energy performance of the building other than dwelling. Minimum threshold backstop U values have been advanced to be the same as dwellings. So you can see that the walls are 0.21, the roofs are 0.16, and the windows are 1.6. And I suppose importantly, curtain walling. We worked closely with curtain walling providers in setting the backstop value for curtain walling, and that's 1.8. Fabric, the air tightness backstop is 5 meters cubed per hour per meter squared. We require mandatory air tightness testing on all, new non-residential buildings. There's a solar gain check in NEAP or SBEM, and there's also a heating check in the NEAP software to CIP-CTM 52. We've separated out the sections for existing buildings into extensions, material alterations, material change of use, major renovations. So we've made it clearer in section 2 of TGDL where each of those lie. And then the other thing was on material change of use. Buildings other than dwellings, they have a change of use more frequently. So what we've done is we've picked the 1991 value as a threshold value. So if your current building has a worse U value than it would have had in 1991, when you do a material change of use, you have to upgrade the fabric on the building. So we were conscious that buildings other than dwellings go through material change of use more often than dwellings. So we introduced this threshold for buildings other than dwellings. Major renovations, so it's major works to more than 25% of the surface area of the building envelope, where you strip it back to the structure of the building. And what we say then is that if you do major renovations to a non-residential building, they should upgrade your heating system where it's old and inefficient, upgrade inefficient heating systems, upgrade inefficient cooling and ventilation systems, and upgrade the inefficient general lighting systems. So the intent is where you're doing a major renovation, where you're gutting a non-residential building, that you'll upgrade the services and the controls as well. When we do the calculations, they're shown to have the best payback in non-residential buildings. As an alternative to following the menu of options, we have a set of whole building performance levels that are a cost optimal level. So if you decide you don't want to do the menu of options I just gave, you can do a SBEM calculation and you can apply measures to achieve the performance requirements in that table 30. The impact on cost, there's a range of costs from about 1.3 to 5.4% for public sector, for private sector buildings. And then we've also, in the regulatory impact assessment, we've also done a calculation on the percentage of roof area needed for photovoltaics for non-residential buildings. But just to say that buildings that have high process loads, we've stated in the TGDL that we're removing process loads from the HVAC. So the renewables requirement in the final version of SBEM, which will be out in July, will reduce the amount of renewables required for buildings like hospitals, data centres, anything with a high process load. Next steps for NEAP, the NEAP publication, well it's actually going to be July 2018. There's been a delay in its publication. We'll put a cap on the HVAC process loads for the RER calculation. We're adding a new schedule for treatment rooms in healthcare buildings, a new schedule for schools to more accurately reflect schools' performance. And we're also taking a 5-year look ahead on the primary energy factor in both dwellings and buildings other than dwellings. So currently it's 2.08 is the primary energy factor, and it will be 1.94 and 0.323 in the new publication of DEEP and SBEM. And our public consultation documents can be found there at that link. I'm going to finish up there to take questions. I've only got to cover dwellings. Orla's up after me. I'll let Orla do buildings other than dwellings, if you're comfortable to use my slides. And I'll take any questions now that you have on dwellings.
Thanks for that, Sean.
Okay.
So the 20% requirement for renewables or on-site or nearby renewables, do you see that being mostly voltaics on the roof or heat pumps or?
If we're talking about dwellings, I suppose we've modelled two examples. We've modelled gas boilers with photovoltaics, which is a common example. That's what we don't pick the renewable. We set the performance requirement and we let the industry decide what renewable they're going to use. So what's being used at the moment is gas boilers with photovoltaics or heat pumps. I think gas boilers are making up something like 55 to 60% of the market, and heat pumps are making up 35% of the market. But the rate of increase of heat pumps is 8% per year over the last 2 years, so they're rapidly increasing. But again, I have to emphasise, we don't pick the renewable, we let the market decide what the renewable is.
Thanks, Sean. Any questions on the floor?
Just in relation to dwellings, what about one-off dwellings? I mean, in terms of compliance with Part L, if they don't have to comply with BCAR at the moment, is there any?
Sorry, I just didn't hear the first part.
In terms of one-off dwellings, you're talking about dwellings within a scheme or something. Is there anything coming down the line that they have to comply?
So I suppose first of all to say that even if you choose the opt-out, you're still required to comply with building regulations. The opt-out means that you don't need the assigned certifier, and that gives you the opt-out from. But you still have to comply with the building regulations, and the owner still needs to sign a certificate that they've completed the works in compliance with the building regulations. So I think that's an important point. I think the expert panel on concrete blocks did kind of identify the opt-out as being something that we can compliance in one-off dwellings. Right now, there's no plan to change that. That's there in legislation and it remains, and that's really the current situation. But you are required to comply with the building regulations. You don't have to follow the building control amendment regulation compliant process.
Okay, so I'll take over there from where Sean left off, and some of it I'll just give you some more detail. I'm going to go through kind of the methodology changes that we have applied to NEAP and DEEP, and then obviously some of the other considerations in regards to NZEB-Dwellings. So as Sean said, for non-domestic buildings, it's a 60% improvement on the previous regs, which is a significant enough improvement for non-domestic buildings, but it also brings in that mandatory requirement for the renewables, and that's probably one of the aspects where people are finding most challenging on the non-domestic side. Then with the domestic, it's the 25% improvement, and what we're finding is that it's a similar fabric performance level, but you are either looking at the likes of heat pumps or looking at boilers with an increased amount of PV, or looking at heat recovery systems in combination with PV and boilers. Sean mentioned about the primary energy factor. So what we have done is we have looked at a 5-year outlay of the energy use and the energy projections for electricity. It's based on a report that's on the SAI website for Ireland's energy projections. And what we did was we've basically taken all the energy that goes onto the grid and multiplied it by the various primary energy factors for those. So the likes of coal, peat, biomass, oil, and the renewables, the wind energy, and then what that is under the line, and then what's over the line is actually the delivered energy. So what's actually going into the buildings at the grid connections, and that gives us the primary energy factor. We're taking a 5-year outlay, and the idea is that we will keep that for the next 3 years, rather than in previous years we've actually been updating it on an annual basis. And we've had people come back and say, well, my building complied last week and doesn't comply this week. So we're kind of we're going to stick to it for the next 3 years or possibly longer. But it'll give people an opportunity to design their buildings and change appropriately. The renewable energy ratio then, in terms of the calculation methodology behind it, what it is the total primary energy of the renewables divided by the total primary energy within the building. And as Sean said, I don't know how clear you can see the diagram, this is all based on an ISO standard, the 52000 standard, which is the EPBD, the Energy Performance and Buildings Directive standards. And if you can see there on the diagram that basically what they regard as on-site or nearby in terms of the renewables is anything that's on-site, like your PV or your solar panels or heat pumps. Nearby is a district heating scheme, or the equivalent to a district heating scheme. And then off-site, or what isn't allowed for, is a wind turbine onto a grid connection. So that wouldn't be regarded as an on-site or nearby, and couldn't be included within the renewable energy ratio calculation. What we regard as renewables within the methodology are photovoltaics, solar panels, wind turbines, heat pumps, biomass, biogas, district heating, as we said, and CHP. The calculation itself then is we take the generated electricity, so if you look at the likes of PV or wind, it would be the amount of energy that comes off the photovoltaic multiplied by the primary energy factor. And what we've defined that primary energy factor is as grid electricity, which is 1.94, as Sean already mentioned. And that then is divided by the total primary energy within the building. Similarly, for biomass or biogas, it's actually not quite clear on that screen, but so if you look at bioethanol or biodiesel, it's probably more easily read, you can see that the non-renewable primary energy factor for that is 0.3, and the renewable primary energy factor is 1. So the total primary energy factor for all of it is 1.3. So only one out of the 1.3 is regarded as renewable. Similarly, what we'll be doing with district heating schemes is we'll be determining what the renewable contribution is for that district heating scheme versus the non-renewable contribution. And then again, we're in talks with the likes of Dublin City Council and Codema for the likes of the pool bag incinerator, district heating scheme, those kind of systems, where we will be defining what the renewable contribution is from those systems and including it in the calculation. And with regards to heat pumps have actually changed. The calculation methodology has changed from what was there previously. And again, what we're doing is actually just going with the ISO standard, so we're moving towards the European standards. And if you look at over in the corner, if you have a heat pump that has a coefficient of performance of 3, if you get 100 kilowatt hours heat out of that, that means 33 kilowatt hours of electricity or whatever the fuel is going into it. What it means in terms of the renewable energy proportion is that 67 kilowatt hours of it is renewable. It's what is regarded as the environmental energy from the heat pump. Now that is more favourable than the old methodology that used to be there for calculating the renewable contribution from heat pumps. So just to make you aware of that, so it's likely that heat pumps will be used more regularly now. The CHP, again, and it's similar to what was there before, we are allowing for the renewable contribution from CHP to be the saved energy. So what energy we have saved, primary energy we have saved from installing the CHP. So what we do is we'll calculate what the equivalent to what a gas boiler and grid electricity is, minus the amount of energy that goes into the CHP, and that is what that is the saved energy, and that is regarded as renewable under the building regulations. So for buildings other than dwellings, what we have done is we're developing the NEAP methodology. Some of you may all be familiar with SBEM, which is the Simplified Building Energy Model, which is what has been out there and on the market for a number of years. So we are working with BRE and the likes of the HSE and a number of other public bodies in terms of developing that software. There is front end interfaces for that, the likes of IES and Design Builder. There's a number of packages that actually feed into the SBEM engine. But we're also trying to develop or move forward in looking at dynamic thermal modelling. So any of you who are familiar with BIM and the whole building information modelling, we're hoping that we will develop or get the software developed on dynamic thermal modelling to allow for a more accurate reflection of the energy use. As Sean said, Part L compliance is going to be based on your building versus a reference building. And to break that into figures for you, what we're doing is there's a set temperature, there's a set occupancy, a set equipment, that's all based on profiles in the software. And what we're doing is comparing the installed hot water, installed lighting, installed fabric and installed HVAC systems to that of the reference building. The reference building is then defined in Part L, and if you are better than the reference building, then you're in compliance with the regulations. For those of you who are familiar with BER, it's a similar process, but what you do there is compare your building then to a notional building. Now, we're not changing the parameters in the notional building, so a B1 that you got last year will be the same. If you do the calculation again this year, it will still be a B1. We're not actually changing the notional building criteria. The notional building used to be the same or similar to the reference building previously, or previous to the old regulations. So that hasn't changed. It's actually just the reference building that we use for Part L compliance that is going to change. As Sean said, what we're finding is the likes of hospitals where you've got high process loads, or the likes of the forensic labs where, again, there's high process loads. We are working with BRE in terms of developing software, and this is one of the reasons why the software is kind of slightly delayed, is that we're trying to get that process load out of the calculation. So we are comparing you to a reference building, and Sean mentioned earlier on that the performance of the reference building in terms of cooling is 4.5 is the seasonal performance of the chiller, but the system seasonal performance is 3.6, which is equivalent to chilled beams. So it's a very efficient cooling system. Whereas when you look at process loads or operating theatres or any industrial clean rooms, they have specific requirements in terms of what they need, the services within them. So what we're doing is we're actually changing the reference building for them, or changing the parameters where you have specific process conditions that you'll be able to compare yourself to a like for like, rather than having to compare yourself to the chilled beam system. Similarly, the calculation for the RER, the RER is really only to do with regulated loads, or what we call regulated loads. So equipment and your computers, or if you think of on the domestic side, your fridges, they're not actually part of the regulated load and are not included within the RER calculation. So again, part of the software update that we're doing is actually pulling out the things that aren't included within the regulated load. So like of those process HVAC loads, we're pulling them out of the calculation in terms of calculating the RER calculation. Other changes we're doing, and again, we have been in discussions with a lot of the public bodies, is looking at the activities. So the likes of schools, we're making them more Irish specific. So if you think of the Irish school year is actually, or the primary school year anyway, is a month less, or 3 weeks less than the UK school year. So again, we've updated a lot of the activities to reflect, or specifically in relation to schools, we've updated those activities to reflect the Irish school year. This was based on a consultation with the Department of Education. Similarly with the Department of, or the HSE, we've got specific requirements for the Irish market that they've pulled out and identified on the Irish market for the HSE. So that's part of the activities that we're doing at the moment. Other things that, again, we are kind of updating the whole software process to look at other things like more than one source of heating and things, making the software a bit more user-friendly and more accurate reflection of the energy use. So to give you a couple of examples of buildings that comply, just to give you a flavour, this is an office building. So in terms of the walls, U-value, it was 0.2, the roof was 0.15, the floor was 0.16. So it's similar to what we're using for dwellings at the moment. It's not over the top. Glazing was actually 1.8. It wasn't. It was just a form of double glazing. Air permeability was 3 metres cubed per hour. The thermal bridging was equivalent to the ACDs. The servicing strategy here was natural ventilation with split systems in meeting rooms. It did have full monitoring and targeting on the lighting and heat back. The efficiency of the heating was 92%. The cooling efficiency was 3.5, which is your air conditioning. Lighting was LED lighting and it had full occupancy controls. And the PVs, the photovoltaics, it was equivalent to 12% of the floor area. And the reason I'm showing this example is when you put in a full fan coil unit system into that building, the photovoltaics goes from 12% of the floor area up to 23%. So it's nearly doubled the amount of PV required in order to comply with the RER. So the servicing strategy that goes into your building is now going to impact on the RER calculation and may dictate which way your building is going to be serviced. This is just another example of a laboratory building. And again, you'll see here that because this was a more air-conditioned building and we had a variable air volume system in the labs and a lot more cooling, we did have to do more in terms of the fabric in order to achieve compliance. And we also had to do more in terms of the lighting, in terms of bringing the efficiency or improving the efficiency of the lighting. So again, it gives you a flavour of what is required. One of the things I will say is that NEAP and the software methodology, it does look at, it's an asset rating. So what it's there for is to compare your building to another building, and it's an asset rating. It's not going to look at the total overall operational performance. So it will have set occupancy, set weather, set temperatures, set equipment, set usage profiles, and set water demand. So really, we're saying you should be looking at doing energy efficiency design, which is one of the directives, CN 399. So it looks at the operational performance of your building, and it's something that people should are cognizant of when looking at the building design. On dwellings then, again, Sean commented on some of this already. What we found with the regulatory impact assessment is that the likes of apartments and small houses were finding it difficult to comply because of the water demand was so high. That we were pushing everything so well, it was so well insulated and had so little heat losses that you can see on the diagram there that the water demand was nearly 75% of the total energy used within the building. So what we did do was look at the calculation in terms of the DEEP methodology, in terms of looking at calculating the water demand. If you have flow restrictors on your tap or on your showers, or if you're achieving a certain water target, you will be able to get credit for that within the DEEP calculation going forward and be able to reduce the energy associated with it. Sean also mentioned about the lighting. What we found, part of the lighting is not only are we allowing for the likes of LED lighting and more detailed calculation. What we're actually asking designers to do for new build is to actually put in the details of their calculation, so that if they are over designing the lighting, that they're going to be penalised, or if they're under designing the lighting, they'll be penalised. So they have to get the lighting correct in terms of achieving the right amount of lux levels for a home, and then obviously taking into account the efficiency of that lighting system. Other changes that will be coming in as part of the DEEP calculation is, again, we will allow for fixed cooling going forward. So SEAI, we're finding that for new build or new apartment blocks, people are putting in reverse cycle heat pumps. So if there is cooling installed, it will be accounted for in the calculation going forward. Another issue that we found a lot, and that might impact on yourselves more, is on the curtain walling systems, that where you have large apartment blocks and how we account for curtain walling, and we'll be providing clarification around that. And then wastewater heat recovery. So where you have wastewater heat recovery, we'll be able to account for it in the calculation. So just other factors then, renewables, as I said, what we're trying to make sure is that it's not just a tick box exercise. We don't want people just installing PV on a home, and I mean, I don't know if you've heard the stories of PV on the roof, but I've never actually put in the inverter to actually connect it to the home. But you know, it's those kind of things that we want to make sure that it's fit for purpose. So obviously there's a number of things that you should be considering in terms of, you know, if you look at biomass, have you got adequate storage? How are you going to get the fuel supply? If you've got heat pumps operate at a very low, or operate efficiently when it's at a low temperature. You know, is the system applicable to it? You can't be sizing it, your radiator in a traditional way. You'd have to be sizing it as a low temperature radiator. Or if you have an air conditioning system, you know, you couldn't put in fan coil unit systems, or you shouldn't use fan coil units because it'd be operating at a higher temperature. Solar panels then, similarly, have you got the space and will it meet the requirement? PVs, again, as Sean said, what we found with those kind of, some of the city central locations, that we didn't have adequate space for PVs. So again, we also have to consider overshading, how well overshaded or how much are they overshaded, and are they going to give us the demand. CHP then is, we need to look at the demand for the heating and electricity on the site. Wind turbines, obviously the site restrictions, and then district heating we kind of touched on. In terms of the key design considerations when it comes to NZEB-Dwellings, is it's looking at the building envelope in terms of the overall performance of the building, but it's also looking at the building services and the servicing strategy around how we're going to implement it. But then also on the UN factors, we need to consider the thermal comfort and that side of it in terms of the building occupants. Thermal bridging is becoming a big factor because we are insulating it these buildings so well and creating these airtight spaces. What we're finding is that some of the ways of complying, or some of the easier ways of complying, is when we get into the detail of the thermal bridge and make sure that they are actually appropriately designed. And then you'd have your thermal modelers actually produce details on it. So that's one of the, again, the number of people have commented on that. That's one of the ways to achieve compliance, and one of the easier ways to achieve compliance. As Sean said, internal environmental quality is becoming more critical. The overheating, one of the things you will see on the non-domestic side is that there is an overheating calc within SBEM now in terms of the solar gain, and what you're doing is comparing yourself to a 1 metre high east facing window. So if you think of one of your buildings and it has full height glazing, the length of the facade on the south facing, it's going to compare that to a 1 metre high. I think the G value is around 0.6, and it's going to compare to that. So it means that your G value would nearly be down at 0.2. If you have a 3 metre high, it's going to be compared to a 1 metre high building or 1 metre high window. So it does come up as a non-compliance now as part of the Part L compliance report that comes out of the software. So it has it may impact going forward on people's designs. The overheating, as Sean said, it is touched on in Part L in terms of there are guidelines in terms of carrying out overheating calculations. On the ventilation side then, because we are moving to these airtight constructions, we need to consider ventilation, and what we're finding, and as Sean mentioned in terms of Part F, where they're going with Part F is because it's now below the 5 metres cubed per hour per metre squared that is going to be required for dwellings. It means that you're going to either have to put in larger openings or for natural ventilation, or you're going to have to look at like the heat recovery systems. And then finally, it's about engaging the building user. The diagram there that I have, or the photograph I have there, is a fuse board. Very glamorous, I know, but what the fuse that is actually switched off is a heat recovery system. This was a social housing building that I went to visit to look at their spanking new heat recovery systems that they'd all installed. And this was in the peak of winter, and the homeowner had the heat recovery system switched off because it just annoyed them, continually running, and they had the window open. So again, part of this process, and as Sean said, in terms of user guides, it's about engaging the homeowners or the building owners and bringing them through the process and telling them how they're going to achieve the energy efficiency in terms of the final operational performance. So I think that's it in terms of my side of it. I don't know if anybody has any questions.
I think John had mentioned that maybe there was a 2% uplift in cost when you apply, when the new regulations kick in and whatnot. I presume the payback is quite short, and that's you know, in terms of energy savings and that.
Yeah, so the building regulations was based on cost optimal study, which looks at the whole life cycle cost of the systems. So that's where the regulations were defined, was based on that cost optimal study. In terms of simple payback, you know, some of the technologies may not be that, you know, but PV probably wouldn't have like a 5-year payback. It might be a bit longer in terms of a 10-year payback. So the technologies will vary, but in terms of the overall life cycle, and the life cycle assessment that was carried out as part of the cost optimal study, that's where we found the definition for NZEB comes from, in terms of where we put the reference buildings.
Any questions on the floor?
You mentioned there NEAP software, NEAP. Is that to replace the DEEP, or is that?
So there's two. So DEEP is the domestic energy assessment procedure, and NEAP is the non-domestic energy assessment procedure. NEAP was the official name, but people used to call it, there's meant to be 3 ways of using NEAP. One was SBEM, which is what people probably know more familiarly as SBEM, which is the Simplified Building Energy Model. But NEAP incorporates using dynamic thermal modelling as well. So it's just an acronym in terms of NEAP is the non-domestic energy assessment procedure. So it won't replace DEEP. It's just looking at the non-domestic.
The non-domestic.
Yeah.
But is that, will all the software for compliance be available with the SEI for free?
So what will the SBEM will be available for free, which is the Simplified Building Energy Model. DEEP will be available for free, which is the domestic energy assessment procedure. The dynamic thermal modelling will be commercial companies who will be producing that. Now we're talking to them about developing the software, but it'll be up to them. They'll be charging up, obviously. In terms of they're doing it at the moment, it'll be the likes of IES or TAS or Building Design or some of those dynamic thermal providers who would be producing the software.
So it's not actual NEAP software, that's the SBIM is used for that.
Yeah. Yeah.
It's not a different software.
Yeah.
Ola, is there any plugin available for Revit for doing daylight or lux level calculations?
So basically Revit, it is a BIM software, so it can feed into the likes of IES. Or you can pull it into the likes of IES and TAS that have daylight calculations built into them, and you can use. That's one of the reasons why we're moving down or pushing for the dynamic thermal modelling side, because then you'll be able to account for those simulations in terms of the daylight and solar.
You won't know that your building is overheating or not.
Yes, and that's where you'd actually do your overheating calculation as well. So that is kind of on the BIM side. I think that's there already in terms of you're able to pull models from Revit into. I only recently joined SEAI. I was out in private practice for 20 years, and we used to basically pull it in from Revit into dynamic thermal modelling software.
Any other questions? I think Sean had mentioned that maybe there will be extra requirements for construction quality and commissioning, and you mentioned inspection of mechanical ventilation, etc. Is there going to be further requirements? Maybe a question more for Sean and yourself, for additional construction commissioning compliance checks, or is it still a sort of self-certification type process?
Yeah, it's still a self-certification process. Now, in terms of building control, I know that I've been speaking to Sean about, obviously on the BER side, we have a kind of a very detailed QA process, and what we're trying to do possibly is bring some of that into building control, so that you know, that, and even the reports that get produced, that are produced by the software, that building control will be able to use those a bit more efficiently to see whether they're compliant in terms of the energy side. But in terms of one of the things, like what we're doing with WWETB, which is that they're water experts, in terms of training on the contractor side, and they are kind of developing modules around, or developing specification for modules around the whole construction side of it in terms of the fabric and all the rest.
And they're training courses for the general operators themselves and the craftsmen and...
Yeah, so what we're hoping, so basically what we're doing is developing a specification for it, and that will hopefully be rolled out nationally then. But it is, look, it'll be the likes of your bricklayers and your plumbers and your foremen is
Yeah.
the way it's going.
Any final questions for Orla?
This might be a question for Sean more than yourself, Orla. Is there any, the ACDs, is there any plan to kind of maybe add to them, or?
I know Sean, I know Sean would love to, and I don't know that there is any. I know on the retrofit side, because major renovations is coming in as well as part of it, and SEAI are involved in a number of deep retrofit. We have a deep retrofit pilot in terms of a grant scheme where we're upgrading the whole fabric and the systems within the homes. I know on the deep retrofit side, we are looking at developing ACDs a bit further in terms of the retrofit element. But again, I know that there is talk of it. Now, there is a database for BRE. BRE have a database on accredited construction detail as well for specific suppliers. So say, you know, Kingspan have a detail that they want to put up, they get it certified, and it goes up on the BRE website that you can actually download as well, and that is acceptable for...
That is acceptable.
Yeah. Then I know that some thermal modelers will say to you, well, actually, and some of the details are now actually going so far away from where the accredited construction details is that you actually will just have to start going and modelling a lot of them anyway, because they are varying significantly from kind of the standard formation. But I know it's on Sean's radar. I can't tell you whether it's going to he's going to publish any in the near future or not. But
no, it does seem that every scheme has to have thermal modelling done for specific details, but there's such a amount of people that do the work. And
yeah. No, I know we are aware of that now. As I said, so BRE do have a database that is acceptable, and that's typically a manufacturer of a system will kind of submit it to BRE and get accredited for it. But we're also providing guidance, and we're also looking in terms of the whole methodology at you know, where thermal bridging modelling is required as well. So just to expand on that as well, just because I think there is some confusion out there. So I think some people think, you know, it is certain details that are required under the scheme. So I think we will be kind of giving some clarification around that.
Just going on, I'm not quite sure what you're saying there. Are you saying that the ACDs are not going to be acceptable?
Oh no, ACDs are acceptable. Yeah, no, sorry. I think you were saying could we expand on the ACDs? The ACDs are acceptable, and so if you've built your building to that construction, they're more than acceptable. But what we are being told by the market is that basically builders are actually going off and developing a completely different construction that aren't accounted for in the ACDs, and that people are having to model them anyway because they're not as per the ACDs.
Any last question for Orla? On that basis, Orla, I might just invite our community member Paul to give both thanks for the lecture.
Thank you.
Well, I guess on behalf of the committee and all, and thanks very much for coming in, and we appreciate it, time after work and all the rest of it, and very informative, and we look forward to seeing these new dwellings evolve over time.